lesson related with thermal physics. Okay, it's Thursday. I hope you are prepared. You have pen, pencil, you have your Tsokos notebook and calculator. So let's start with your homework. Do you remember? You had to do 10 multiple choice questions from your Tsokos, page number 141, 142. I hope you did this. So let's check your answers. Here you have Tsokos answers found in Tsokos book for teachers' resources. The correct answers are first A, second B, third C, fourth D, fifth B, sixth A, seventh B, eighth A, 9D, but there is additional information. The question should have specified equal moles for each gas, and exercise number 10A. Okay, so please check your answers now. Mark and write in the post how many points you scored. Okay, if you let's try to find correct way to correct answer in the case if your answers are wrong. Okay, so let's now if you see correct answer, you can compare and you can find solution. If still something is wrong, if you don't understand something, write me in the Google Classroom. On next lesson I will try to explain better. Is that clear? Okay, so stop video for a moment, check your answers, and when you will be ready, turn it back. Okay, few minutes later, I hope that all is correct, that you understand correct answers. So let's open your Tsokos on page number 143, and today we'll do few exercises, exam style questions. As you know, these questions are very important because usually they occur on the final exam. So Tsokos page number 143 and exercise number 11. Okay, I see that there is small mistake here in A, so let me read first. Correct, just in A. Calculate the volume of 1 mole of helium gas of molar mass 4 grams per mole at temperature 273 kelvins and pressure of 1 times 10 to the power of 5. Should be 10 to the power of 5. Is written 105 pascals, so please correct this. I think that in new edition of Tsokos, some people have a new edition. Yes, in new edition of Tsokos, this is correct, so I'm going to correct this. It should be 10 to the power of 5 pascals. So people who have 105 should write 10 to the power of 5 pascals. Okay. And now, you have 4 points A, B, C, D. One is split into 2 others, and together you can score 11 points. 11 points means around 16-17 minutes examination time. So please stop video for, let's say, 20 minutes. Turn your watch, check the time, and you have 20 minutes to solve these 1, 2, 3, 4, 5 questions. After 20 minutes, please turn on a video, and you will be able to check your answers with my answers or with my way to obtain correct answers, because still I don't have calculator. My calculator is broken, so I'm not going to calculate from the very beginning to the very end. I'm going to show only way how to find it. Is it clear? So please stop video for 20 minutes and solve these 5 exercises. Okay, after 20 minutes. So let's check. In the case of A, I'm going to use blue for A. Okay, you have to find the volume of 1 mole of helium gas at temperature 273 kelvins and pressure 1 times 10 to the power of 5 pascals. Of course, Clapeyron's equation, PV is equal to nRT. Question is about volume, so you can write this in the form nRT divided by P. So, to find volume, you have to know number of moles, which is given 1 mole of helium. Is it clear? So 1. times R, which is gas constant in standard units, is equal 8.31. Temperature in kelvins is also given directly. It's 273 kelvins. Divided by pressure, which is also given. Yeah, so divided by 1 times 10 to the power of 5 gives the answer, which, okay, I can calculate this. It's not difficult. 8.31 times 273 and divided by 10,000, you can move dot by 1, 2, 3, 500,000, move dot 5 places left, so it's 2.27 times 10 to the power of minus 2. Standard units, so meters cubed. I hope this answer is correct and your answer is the same. If I have some mistake in calculations, right, as a post, okay, sorry, I don't have calculator. B red. B1 and B2 by using red color. Okay, find out how much volume corresponds to each molecule of helium. Okay, so first of all, you have to find number of molecules. I hope that you remember equation that number of molecules is number of moles times Avogadro constant, because number of moles contains Avogadro constant of molecules. Yes, we have 1 mole and Avogadro constant is given in your data booklet. It's somewhere here, 6.02 times 10 to the power of 23. Okay, so the number of molecules is 6.02 times 10 to the power of 23. Okay, but this is not the end of this point. We have to find how much volume corresponds to each molecule. So volume occupied by one molecule, let's name it V1, is total volume calculated in the previous point divided by number of molecules. So basically you have to divide 2.27 times 10 to the power of minus 2 by 6.02 times 10 to the power of 23. Okay, I'm able to calculate this. 2.27 divided by 6.02 is 0.377, so I have 0.377 times 10 to the power of minus 2 and minus 23 is minus 25, which can be written as 3.77 times 10 to the power of minus, okay, this is the part, so smaller, minus 26 meters cubed. Okay, so in my opinion this is the answer for B1. So now B2, still red color. And diameter of an atom of helium is about 31 picometers. Discuss whether or not the ideal gas is good approximation to the helium gas in A. So let's look. Let's calculate approximately, okay, the volume of one helium atom by using this diameter. Yes, so if diameter is equal to 31 picometers, okay, then radius, which is needed to calculate volume, is equal to half of this, so 15.5 picometers. Pico means milli, micro, nano, pico to the power of 12, so 15.5 times 10 to the power of minus 12 of meters. So now let's calculate volume of the sphere of radius, I'm going to use S, sphere, of radius 15.5 times 10 to the power of minus 12 of meters. So volume of sphere is 4 over 3 pi radius to the power of 3. So in this case is 4 over 3 pi times radius 15.5 times 10 to the power of minus 12, and this is to the power of 3, which gives, I'm going to calculate this, 4 over 3 equals, times pi, I'm going to use 314, equals, times 15.5 to the power of 3, so times 15.5 times 15.5 times 15.5, Okay, so I have around 15,600 times 10 to the power of minus 12 to the power of 3 is minus 36, which can be written as 1.56 times 10 to the power of 1, 2, 3, 4. I moved dot by 4 places, so 10 to the power of minus 32. Okay, and what is the answer? Let's look. Ideal gas, one of the assumption of ideal gas is that size of the molecule is very, very, very small compared with distance between the molecules. So let's look. In this case, we have volume of one molecule, real volume of one molecule, a sphere of diameter of 31 picometers, and this is the average volume occupied by this molecule. Okay, if we have total volume divided by volume of one molecule, we have average volume occupied by one molecule. So let's look. In the case of volume, one molecule occupies space which is around 10 to the power of 6 times less than space which is for this molecule, which means that size of the molecule is very, very, very small compared with distance between molecules. Is that clear? So what is the answer? Yes, the ideal gas model works in this way. Okay, so ideal gas is good approximation. Okay, the ideal gas is a good approximation. Is it clear? Okay, so next, C. I'm going to use blue for C. Consider now 1 mole of lead of molar mass 207 grams per mole and density of 11.3 times 10 to the power 3 kilograms per meter cubed. How much volume corresponds to each atom of lead? So very, very similar problem to the previous one. We know 1 mole of lead. So in 1 mole we have how many molecules? Number of molecules is number of moles times Avogadro constant, so it is 1 times 6.02 times 10 to the power of 23. So we have 6.02 times 10 to the power of 23 of lead molecules. Is it clear? Okay, and now we have two other parameters. Molar mass is 207 grams per mole, and density is 11.3 times 10 to the power of 3 kilograms per meter cubed. Okay, and we have to find the volume of each atom of lead. So we can calculate volume of 1 mole of lead. So let's look. What is the mass of 1 mole? If molar mass is 207 grams per 1 mole, it means that the mass of 1 mole is 207 grams, which in standard units is 0.207 of kilograms. Okay, mass is given, density is also given, so we can calculate the volume occupied by all lead atoms. Volume is mass over density, because density is mass over volume. Is that clear? Okay, so we have mass as 0.207 kilograms divided by density, which is 11,300. It's written 11.3 times 10 to the power of 3. So I can use calculator, built-in calculator, and find this. Okay, so it is 1.83, 1, 2, 3, 4, 5. 1.83 times 10 to the power of minus 5 of meter cubed. Okay, and now to find volume occupied by one atom of lead, or volume corresponds to one atom of lead, we can use the same method as in previous point. We can calculate this by dividing total volume by number of molecules. So by dividing 1.83 times 10 to the power of minus 5 by 6.02 times 10 to the power of 23. Okay, so how much is it? 1.83 divided by 6.02 is 0.304 times 10 to the power of minus 5 minus 23 gives minus 28. Okay, which is 3.04, so it's a part of, so times 10 to the power of minus 29 meter cubed. Okay? And so you see that the order of magnitude is completely different than in the case of helium. Is it clear? So probably it's not a good approximation in the case of lead. Okay, and last question, D. Find the ratio of these volumes, helium to lead, and hence determine the order of magnitude of the ratio separation of helium atoms to separation of lead atoms. Okay, so we have to take this volume for lead and this volume for helium. Okay, and question is about the ratio. Okay, so ratio of these volumes, helium to lead. So it is, this is D. So we have to divide 3.77 times 10 to the power of minus 26 divided by 3.04 times 10 to the power of minus 29. Okay, so calculator, 3.77 divided by 3.04 is equal to 1.24 times 10 to the power of minus 26 minus minus gives plus, so minus 26 plus 29 is plus 3. So ratio is 1.24 times 10 to the power of 3. And there is one more, the order of magnitude of ratio, separation of helium atoms to separation of lead atoms. We have ratio between volumes. How to find a ratio between separation, so ratio between distance. Okay, what is the relation between volume, three-dimensional thing, and distance, one-dimensional thing? The difference is that distance is cubic root of the volume, because volume is distance to the power of 3. Is it clear? Okay, you can imagine something like this, that each atom occupies or travels in space which is a kind of cube. Okay, so if we have two neighboring atoms, then distance between these atoms is, let's say, x. How to find volume? Volume is x to the power of 3. Is it clear? So if you have ratio between volumes, so V helium to V lead, okay, then to find separation you have to take cubic root of this. You see, if you will make cubic root of this, you will obtain that separation of helium atoms divided by separation of lead atoms is the cubic root of volume of helium to volume of lead, and the volume of helium to volume of lead is given here. Okay, so finally I'm going to use a pink here to find final answer. So final answer, separation of helium to separation of lead is the same as the cubic root of 1.24 times 10 to the power of 3, which in order of magnitude is around 10. So 10 to the power of 1. So what is the answer? The order of magnitude of the ratio separation of helium to separation of lead is 1. Okay, so in the case of helium, we have distance, average distance between molecules 10 times bigger than in the case of lead. Oof, nice exercise, really very nice exercise. I hope that you did this in similar way. If not, then please stop video for a moment, check it again, compare, eventually correct, and when you will be ready, turn it back. Okay, and let's do one more exercise from your Tsokos, exercise number 12. Okay, the same rule. Let's try to do this working alone. You can collect 1, 2, 3, 4, 5, 6, 7, 8 points. So 8 points is examination time of 12 minutes. So let's spend with this exercise, let's say 15 minutes. Stop video now. You have 15 minutes to do this. Try to do this in 15 minutes. After 15 minutes, turn video back and check your answers with mine answers. Is it clear? Okay, so after 15 minutes. Okay, A. Define specific heat capacity. I'm not going to write here. Specific heat capacity is the amount of thermal energy which is needed to heat up 1 kilogram of substance by 1 degrees Celsius. Okay, this is definition. You can write the equation and you can eventually write the equation and explain all symbols, but by word you can do this. Okay, B. Consider two metals that have different specific heat capacities. Okay, this is B. The energy is required to increase the temperature of 1 mole of aluminium and 1 mole of copper by the same amount are about the same, yet the specific heat capacities of two metals are very different. Suggest a reason for this. Okay, the reason is mass. Okay, in the case of B, the key word is mass. If we have the same amount of molecules, yes, but of metals which have different molar masses, okay, then mass of each metal is different. Is it clear? So molar mass of aluminium is different than molar mass of copper. Yeah. So if molar mass of aluminium is different than molar mass of copper, then mass of 1 mole of aluminium is different than mass of 1 mole of copper. Is different than mass of 1 mole of copper. Is it clear? Specific heat capacity is defined as amount of thermal energy needed to increase the 1 kilogram by 1 Kelvin. So if we have the same energy, the same Q, yes, and the same change of temperature here to increase the temperature by the same, but different mass, okay, then specific heat capacity must be different. Is it clear? So keyword mass. Okay, C. We have a hair dryer. Consists of two coil that warms air and fan that blows the warm air out. The coil generates thermal energy at rate of 600 watts. Take the density of air to be 1 to 25 kilograms per meter cubed, specific heat capacity 990 joules per kilogram per Kelvin. Dryer takes air from a room at 20 and delivers to the room at a temperature of 40. Find mass of air which flows through the dryer per second. Okay, so let's look. Per second, we have a parameter. This is specific. We have parameter power. What does it mean? Power means amount of energy per second. So if power is 600 watts, it means if this device is 100% efficient, that amount of heat which is delivered is 600 joules in each second. Is it clear? Okay, so if we want to find the mass of air, we can use again the same equation for specific heat capacity. If Q is specific heat capacity times mass times delta T, then mass is energy divided by mass times delta, thermal energy divided by specific heat capacity times delta T. Energy per second is given, it's 600. Specific heat capacity is given, 990. Change of temperature is given because temperature changes from 20 to 40. Okay, you can calculate it. We can cross 0, 0, 0, 0. And finally, I use my powerful calculator. I have to divide 6 by 2, which is 3. So 3 by 99, which is easy because this is 0.303. So 3.03 times 10 to the power of minus 2. Okay, and this is mass, so kilograms, but answer is mass per second. So mass per second is 3.03 times 10 to the power of minus 2 kilograms per 1 second. So this is answer for C. Okay, D. We have to find volume. Okay, so volume, the equation for density. Density is mass over volume, so volume is mass over density. Okay, volume per second, so mass per second. Mass per second was calculated in previous point, 3.03 times 10 to the power of minus 2. And density is given here, so 1.25 kilograms per meters cubed. I have standard units everywhere. My powerful calculator is able to divide this, 2.42. So 2.42 times 10 to the power of minus 2 of meters cubed. This is volume. So volume per second, volume per time is 2.42 times 10 to the power of minus 2 meters cubed per second. Clear? Okay. And the last one, red color E. The warm air makes water in the air evaporate. If the mass of water in the air is 180 grams, calculate how long it will take dry the air. The heat required to evaporate of 1 gram of water at 40 degrees is 2200 joules. Okay, it should be mass of water in air, not air. So probably in air is H is here. Okay, so let's look. We know that we have 180 grams of water, and we know that 1 gram at 40 degrees needs 2200 joules. So first we can calculate how much thermal energy is needed. We have to multiply 180 grams times 2200, because if 1 gram requires 2200, then 180 grams requires 180 times 2200, which is 3.96 times 10 to the power of 5. 396 times 10 to the power of 5 of joules of energy. So this is amount of energy which is needed. Okay, and how long it will take to dry the hair? We have a power. Power is energy over time. Okay, so time is thermal energy over power. So we have to divide 396,000 by power, which is given 600 watts. 600. Again, I'm going to use my supercomputer and powerful calculator to find this. So it's 3960 divided by 6 is 660 seconds. So 660 seconds or 11 minutes, it's the same. It's time needed to completely dry hair. Oof. Okay, how this? I hope you have the same answers. So time for homework. Stop video for a moment, of course copy this, check your answers, copy this. I hope you have the same answers. When you will be ready, turn it back, it will be homework. Okay, so as you know that homework is your Tsokos. So open, you have to do exercise number 13. From your Tsokos, page number is 144. So page number 144, which is of course 12 to the power of 2. Okay, so Tsokos, page number 12 to the power of 2, so 144, and exercise number 13. So today is Thursday, so next lesson is Wednesday, so till Tuesday you have to do this. Okay, thank you for watching. If you have any questions, problems, suggestions, if you don't know something, write post in Google Classroom. And remember, learn physics, stay at home, and see you next time. Bye.